My name is Derek Nener-Plante. I'm a principal in my own engineering firm, just myself, DNP Infrastructure. My background is that I went to school for civil engineering. I got an internship at a DOT in their asphalt paving office, and got the bug there and kind of said, okay, I'm interested in this. Actually got my master's in materials and asphalt, and I've been working in it ever since. I did 10 years at Maine DOT, and went from kind of an engineer to the responsible asphalt pavement engineer for the entire state. And when I was there, I was responsible for all things asphalt construction, design, specifications, disputes, etc. So I have a lot of experience there. After I left there, I went to Federal Highway Administration. I worked there for 5 years in the Resource Center, providing asphalt technical assistance and quality assurance technical assistance across the country. It's Sharon, you mentioned Dennis's passing, which was very sad to hear. I worked with Dennis for 5 years while I was there. He was a friend, and he'll be missed. So, and since that, I left last year, and I've kind of been doing my own thing in the last year. And so I appreciate the invitation by Sharon and Mike and everyone to get me here today. So I want to make this as engaging as an online class can be. All right. Understood it'd be a little bit easier if we were all in the same room. But I'm hoping that you can take a couple things away, and I'm happy to cover any additional topics I didn't cover, or I don't have a slide on. So again, even if you just want to enter into the chat a question, a thought, a topic, please do so. It's better for you if this is someone engaging. It's better for me as a presenter, etc. So I did this yesterday because I did inspection yesterday. And what you'll see once you get the slides, I think, is that I do have some placement slides in there. A lot of the slides I did yesterday for the on-site inspectors. And again, I know some of you are here today as well, right? What I'm going to focus a little bit more today is the production of the mix, all right? And some things on the production of the mix. If we have time, maybe we'll hit some of the placement stuff, but I'm going to try and stay in that realm, in the mixture realm. And so I did do this yesterday, and I'll ask, why are you here? Okay. I'll ask it rhetorically because I do have people who have been here both days. All right. But answers that we received, right? Sharon told me I have to. My boss told me I have to, etc. Okay. My certification is up. It's my time every 5 years. Yes, that may be the reason, right? But the why behind it is important. Certification and the classes that we take and making sure that everyone is on the same page is an important function that we do. I think about, again, my example from yesterday was that I think about my kids. I have taught my kids the same thing 4,000 times at this point. Still don't think they remember it, okay? But we as human beings are not perfect. You can be in this industry for a long time, and it's good to get refreshed, to stay on the same page, to obviously hear what's new. We're going to hear about what's new in your specification and other things, but also let's remind ourselves to be on the same page. Because as human beings, we spend time, we do the same thing every day. You shake rocks, the same rocks every day. You do the same tests every day. If we don't kind of come back together and say, okay, this is what we're trying to do, this is the purpose behind, then we can end up kind of making worse decisions over time. So that is part of the reason why we are here to be part of the class today. And so I have a couple learning objectives that I've listed out here, a couple things that I want to talk about. I want to start with the purpose behind why we are doing this, right? Why, no matter what function, Sharon talked about the different people that are here and the different functions you provide, you still all have a role within a quality assurance system. And I personally believe it's important for everyone to understand why we do it this way, no matter what your job is. We'll talk a little bit about inspection. Okay, again, some of these might be on the slides I might kind of skip or I put towards the end. All right. I want to talk a lot about some production and paving risks, inputs to the plant, some common things that we see at the plant level, at the mix level, kind of those first things to think about when things aren't going well. I also talk a little about balanced mix design, as I know that's a new topic and something that's gaining a lot of steam in North Dakota, as you have Tyler Womuth and others, Aaron Perez, doing innovative things to try and get you better pavements. And kind of give you an overview of why you might be seeing that and some of the new materials you might use. So, again, same slide I talked about yesterday for those that are repeat customers, if you will. But quality assurance is something that we do. And I often ask people, well, why do we do it? Okay, why do we have inspectors? Why do you have testers? Why do you have sampling and all of this? Why can't you just build the roads? Okay. The short version of it, again, much like my previous discussion, is the Sharon told me I have to be here, right? The version of that is that federal highway for federal funding, right? You have to have a quality assurance system. All right, it's mandated by regulation by federal highway on federally funded projects that construction infrastructure projects have a quality assurance system. Okay, so that's obviously the direct why. But why is that there? Okay, why that's there, and the little known or the little acknowledged thing is that as great as our interstate system was, when it was built, we had fraud, abuse, money not getting spent well. And we're all taxpayers. We all want our money to be spent well. We want to assure that what we're paying for, what I'm paying for, what you're paying for, what everyone is paying for, we get what we're asking for, right? It's with government or public money because, if you procure a service, right, from somebody and you're not happy with it, what do? You don't get good food at a restaurant. You just don't go there again, right? You make the choice to not go there again. But we don't do that with public funding, all right? So again, the why is important. We think about the amount of money that we're spending. We want to make sure that we're getting what we're paying for, right? If we design a road to last 20 years, we're hoping it's going to last 20 years, okay? So how did we get here? We got here by method specification. That's how much of the interstate and a lot of the system used to be built. Used to be DOT people, right? My agency people, the people representing the owner, told the contractor exactly what to do, right? Press this button, put in more sand, put in more asphalt, put in more cement, change this, do this. And they just basically rented the contractor, right? Rented their equipment, rented their people, and managed everything. Now we've changed since then, right? Number one, DOTs don't have the staff or the know-how anymore necessarily to run that. Okay. It also puts all the risk on the owner. Okay. They say, press this button, and it results in something that is garbage. Owner owns it, right? I told you what to do. I can't get mad at you when you did what I said and it didn't end up well. Okay. So that's part of what we have as a quality assurance system today, where, as Sharon kind of alluded to in some initial discussion as people were signing on, we have kind of the function of agency acceptance, that's the owner, all right, and what the contractor's job and all these other things that are part of the program. You'll notice personnel qualification and certification. What we're doing here today is a major part of that. Having people who know what they're doing is important, all right? When the contractor wants to know that the people that are made doing testing to see how much they get paid, that they know what they're doing. When the owner wants to see that the contractor, when they do testing, it means something, okay, that they know what they're doing, right? Part of the reason we do this is we give contractors more control over their equipment, their materials, right? DOT engineers or DOT designers, you don't know the aggregate sources like the contractors do, okay, in many cases. And a lot of the job is to have a rational assessment of pay. We used to do a lot of pass-fail specifications as an industry. And when people looked into this, all right, this is real, I promise you, that some DOT specifications, and maybe even some today, maybe you know a couple of them, they were pass-fail. And the spec was written something to the effect of, okay, if you fail 2 tests in a row, you have to remove it or you have to stop. There was some sort of consequence, right? Okay. So when they looked at a project over, this massive project, if you had to guess how many results passed versus failed at the end with that spec, all right? And what the numbers showed, all right, in those cases is that it was almost 50-50 because they went pass, fail, pass, fail, pass, fail, pass, fail, pass, fail, pass, fail. Okay? Because there were no consequences until I failed 2 in a row. So you ended up with a project that almost half of the material failed and paid 100%. Doesn't make a heck of a lot of sense when you think about it. And that's part of the reason we do what we do with quality assurance. And so another point that I made is that this is not inspection and certification and sampling and testing is not something that we dreamed up as our industry. Federal Highway didn't pluck it from an idea from internally, okay? It is everywhere, all right? Quality assurance as a concept is widespread in all of these different industries. Again, I said this yesterday. This is a quality assurance lab at Ben & Jerry's Ice Cream, okay? When I visited their plant facility and you see tests in there, they're bringing the ice cream in and they're testing it to make sure it meets what they want for quality, okay? Healthcare, software development, cars, construction, anything has quality assurance. The things that make us the black sheep when we compare ourselves, when we compare, say, construction or even horizontal construction to maybe vertical construction like buildings, is that we have to deal with higher variability. We have to take rocks out of the ground, all right? And again, I show ledge here. I know you don't have a heck of a lot of ledge, right? You're using natural sand deposits, gravel, etc. But what we take has a higher variability. The asphalt that we take out of the ground, right? We refine out of oil, okay? That has higher variability, okay? So we have to deal with that. Whereas in manufacturing, in all these other industries, they have no tolerance for failure, okay? The other thing that they can do that we can't do is if in a manufacturing plant, if they're making small parts for a car, okay? When they get a failing part, what do they do with it? Just throw it away. Okay, number one, it doesn't happen very often. Okay, but they just throw it away. Okay, we can't reject material that easy. It's already on the road, right? We paved it, we placed it on the road, and the tests come back and they say it fails. Well, it takes a whole lot of money and effort to redo it. Okay. The last thing, and I'm gonna skip past the question because again, the people who heard me talk yesterday will give the answer. I think it's surprising people. These other areas, their acceptance of failure, if you will, of something that doesn't meet spec. How often do you have materials that don't meet spec, right? Within your jobs, I'm sure you see it relatively often, not like all the time, but you see it. It's not like, well, this crazy thing happened today. We had a sample that didn't meet spec, okay? That's how people in other industries feel because many of them hold themselves to only having reject material, something that doesn't meet spec, 0.00001% of the time. Okay. We as an industry accept 1 in 10, 10%. As an industry generally, we are okay if you look at the way we pay and we accept and we look and pay the contractor, we generally are okay with 10% of the material we're given not meeting spec, right? That's why these industries look at us and go, ugh, those guys, all right, what they do is a little crazy. But there's reasons behind that. So this is my big one that no matter where you are, okay, I see the 58 people here today, whether you're testing for the contractor, whether you're in a DOT lab, right, running gradations, or you're doing mixed design as a consultant for a contractor, et cetera, you're going to see yourself fit into here. And I'd ask you to think to yourself, what is my role here? And the two major roles of quality assurance are the contractor and the agency, contractor and the owner, the person who's buying it, okay, and the person who's providing it, all right, who's getting paid to do something, right? So the contractor is providing or making something and getting paid to do it. The owner is taking possession of it. It's theirs, okay, and they're buying it. Okay? So the contractor is fully responsible for quality control, right? A colleague of mine says you can't inspect quality into a project. He doesn't mean that like inspectors don't matter, all right? What he means by that is unless the people doing the work want to do a quality job, you can't just inspect it in, all right? The people running the equipment, running the plant, making the aggregate, processing the aggregate, they got to want to do and do a quality job, right? Now, it's also the contractor's job to ensure that the process, that what they are making meets the spec, okay? Let me pause for a second, go to the other side. The owner, right? DOT, whoever it is, it's only your responsibility to figure out how am I going to figure out what the quality of this product is and how much am I going to pay? Okay. I like to say, specifications are something that joint, agencies and contractors, they work on, right? Your specs. But in the end, the person who owns it is the owner, is the agency. The agency's job is to write a spec that will get good performance. It's the contractor's job to meet the spec. Some people kind of think about, well, it's the contractor's job to give you a good mix. It's the contractor's job to meet the spec. It's the owner's job to write a spec that will result in a good mix. I know that's a slight, semantics maybe, or the words and just wordplay there, but I do think it's an important distinction. Contractor's job is to meet the spec, right? Owner's job is to make sure that spec is good and gets me performance, okay? And then once we get into production, again, the contractor's in control of their process, right? They're making the mix. They need to make adjustments when necessary to keep it in spec, to keep it consistent. And they're going to do this by sampling, testing, inspecting, corrective action. The owner, all right, which I'm kind of getting the feeling a decent amount of you are in some of the labs, et cetera, doing some of this testing, all right, you are determining the value, all right, and therefore payment of what you're buying. So this includes sampling, testing, inspection, all right? Now, your results, the contractor is going to use to maybe you make changes, but that's not your concern. That's not your primary concern, right? You want to make sure that I'm measuring the quality of the product well, so I know how much to pay you for it, right? So these are two distinct things. Now, you use contractor results and acceptance, it muddies these waters, but it still doesn't change these roles. And so what am I talking about specifically, right? What activities in an asphalt mixture world would you see and where do they fit? Okay, so acceptance, all right? This would be something like mixed samples, at the paver or at the windrow, right? And we tested for, I don't know, asphalt content, volumetrics, gradation, maybe some BMD tests. This is actually a picture from North Dakota, all right, of some of your Hamburg samples, all right. Cores is an example. We talked about that with inspectors yesterday. You all take cores for acceptance, right? This is an example of the acceptance function, all right. You're looking as much as possible at the end product, as much as you can, and figuring out, okay, what's the quality of this? Therefore, how much do I pay for it? Okay. Quality control, all right, is by the contractor. Something here might be, again, mixed samples at the plant. I know that's not common for you, all right. But either way, mixed samples at the windrow, all right. Again, tested for asphalt content, gradation, air voids, something along those lines. It's maybe a little bit simpler distinction in the field. This is where QC is often doing nuclear density gauge testing during rolling operations, right? They don't have the time for the cores. They need quick measurements because they need to make changes. They need to make adjustments, right? Their primary concern is not how much they're going to get paid. I want to make sure that I'm still meeting spec, okay? And then process control is actually a subset of quality control, where these are things that the contractor does of your own volition. No one's telling you to do it. A lot of QC is something that's in a spec that says you have to do this. Okay. Some agency specs have heavier QC requirements than others. Process control is something they do completely by themselves, right? Like an example for this, for me, in a lot of cases, are stockpile gradations and moistures. That may or may not be required by the spec, but in order to make sure that I get good results for acceptance, I better be doing them. I gotta know my materials. All right. And this is the distinction. And I'd ask you to kind of ask yourself, where do I fit in here? What testing and what activities do I do? Where am I fitting in these different roles? An additional one, again, is inspection. All right. We can test all we want. I know we have a lot of testers in this room, right? So I'm not downplaying the role that you have. Tests tell us a lot, but it doesn't tell us everything. Okay, I can't just run one test a day or two tests a day or three tests. I don't care how many, 10 tests a day on an asphalt mixture production and know everything about how that pavement is going to perform. All right. We have a product, asphalt mix, asphalt pavement, all right, even concrete, ugh, all right, not a big fan of concrete, but aggregate, whatever, that a test doesn't tell the full story, right? How I build something matters, not just the test at the end of the day, okay, all right? So you have inspection is necessary to look at the quality of the process, how it is being done. Right? The quality of the product itself, all right, the mixture, and the quantity of the product. That's again more of an inspection in the field thing, all right? And you want to know what the reason for any sort of deficiency or defect, because it's going to happen. It's going to happen. And also assist in resolving disputes between parties, right? When we don't agree, when our tests don't agree, whatever that case may be. Okay? Our eyes, our ears, all of those things are useful, okay? Whether you're representing the owner agency or whether you're representing the contractor. Either one, inspection is important. And so within inspection and a quality assurance system, your production and QC staff are doing inspections, hopefully, where you're looking at production and placement activities. We'll talk about some of those things in a plant that I often see that if I go in a plant that's having some issues, what are the first things I'm going to look at? Okay. The owner agency, you're conducting inspections. All right. Not only looking at the product, but I'm looking at the process that's being built. And I'm also looking at the contractor's QC. All right. If your spec requires the contractor to do QC testing, you are paying for it. It is a service, all right, that provides additional assurance that things are meeting spec, because QC is more often than the owner tests, right? Owner tests, maybe QC does 4 tests to every 1 for the owner. So it's happening more often. To me, that's a service to have additional confidence, assurance that things are meeting spec. Okay. And so talked about this again with field people a little bit yesterday, but this could be at the plant. This could be anywhere, any inspection operation. All right. I don't care whether it's just the owner, could also be the contractor for those of you doing QC. If I'm doing real inspection, if I'm really inspecting, I'm going to do 3 things. Okay. I'm always observing the materials, the process, what are the results. Okay. Even for my testers out there, right? You may think, well, I'm just a tester. Okay. Well, how does the material look? Has it changed? All right. You can still learn something other than just the test. So looking at all of that, documenting is important. If you are specifically an inspector of some sort, your word is your word, right? Documentation of the time is what matters. If you ever get into a disagreement, a dispute, documentation is what matters. Not, yeah, I remember we were over here. Da, da, da. Nope. Is it documented? Then it doesn't matter if it's not documented. So these are objective facts, times, temperatures, locations, quantities. Again, QC is the same way. If you're doing QC, document what you see, right? Not just I fixed it. Fixed it is fine, but I don't learn anything from it if I don't document it. And if there's a problem, let's communicate on it. So I have this kind of example. Here's what I see. Here is the requirement. Here's what I need to do. Okay. And again, sometimes, or most of the time, we want to be proactive because it's something that's still fixable. Okay. It's something that I can maybe what I just did, the mix I just made can't be fixed, right? There's an issue. All right. It is what it is. I can't put that toothpaste back in the tube, if you will, but I can at least change for the next 2,000 ton and make sure the next 2,000 ton isn't having the same issue. So I showed this yesterday, again, more of a placement thing, but if you see an issue, what's the first three things you do? All right. Whether, again, it's a production issue, whether it's a placement issue, this is a technical term, bad looking map. Okay. All right. So what would I do? Again, I'm just going to show this as again, I know we're more testers in here. Number one, we got to notify someone if something is going wrong. All right. If something is not meeting spec, plant, field, I don't care. If something is going wrong, we need to talk to somebody who can actually do something about it. And this is maybe aimed towards our agency people. You aren't in control of the plant, right? You're not controlling the plant. You're not controlling production, right? You need to notify somebody who can make some corrections. You want to document what the heck is going on, all right? Not just walk past it. Oh, you have an issue back there, okay? Doesn't matter whether they're going to fix it or not. Doesn't matter. Okay, you document that it happened no matter what. Right? Your job is to tell the story of what happened on site that day, not whether everything was okay or not when you're an inspector. And then some expectation for corrective action. Right? We're out on XYZ on this mixed property. We need to get back in by the end of the day, or I'll give you this period of time, whatever it is. Okay. And so those are some general thoughts I have on inspection and everyone's role. Okay, testing is a certain part of that, right? And as testers, you have an important role in that. So what I want to spend most of our time after that brief introduction is in asphalt mix production, right? I know, again, some of you may not deal with asphalt mixes, you may have different jobs, etc., but this is where I want to spend the bulk of my time today. So making an asphalt mix, all right. Yesterday, again, for those that were here with me, we were talking mainly about placing it. Today, I want to talk about making it. So if I think about what am I trying to do, what's my goal, if you will, when I'm making an asphalt mix, I want to take the different constituents or the parts, okay, proportion them correctly, heat them up when necessary, and mix it into a uniform mix that meets what I'm trying to make. So I have a mix design, a job mix formula. That's what I'm trying to make. I'm not just making hot top or whatever comes out of the plant. I want to actually make what I'm trying to make. That's why we spend all that time doing a design. So I want to make that, and I want to make it consistently. So the plant's job, an asphalt mixture production facility, all right, a plant, it's to combine these different parts, aggregate, binder, wrap, etc., together, do it consistently, and discharge it into the transportation. Okay, that's its job if I really back up. So how are the ways that a plant actually does that? Okay, number one, if I kind of step up, no matter whether you're a tester or something like that, I said this yesterday again about equipment. If you're testing the material, I think you should know how it's made. Not enough to run a plant, but I think you should be able to, have an idea of how it's made. So what is a plant attempting to do? Okay. A plant is trying to proportion, all right, the aggregates, asphalt, any additives, any other materials, right? So I have my formula, my job mix formula here, right? Okay, this piece of paper, it calls for 20% of this, 30% of this, et cetera, 5.6% asphalt by weight, whatever the case may be. Okay. I want to make that. So I got to proportion those aggregates, asphalt, and additives. So I got to feed those into the plant. Okay. Feed my aggregates and cold feeds, my wrap and the wrap collar, binder comes in. Okay. Then what do I got to do? I can't just mix the aggregate like that. This isn't concrete. Right? This isn't concrete where we want a certain amount of water. So if my aggregate is a little moist, no big deal, right? And I can account for that. We need our aggregates dry. We don't want water. All right. Now, if you use foaming warm mix, I'll talk later. I'm not going to talk about that, I guess, but there are some small exceptions. But for the most case, I don't want water in my system whatsoever. Water is the enemy, right? We want to keep it out of our asphalt mix. So as such, aggregate that's just sitting out in the wild, right, is going to have some water. It's going to have some moisture. Doesn't matter whether it's been dry for 2 weeks, no rain, it still has some moisture in it. Okay, so I've got to dry it. I got to dry it completely. Then I've got to heat it up. Okay. I got to make hot mix asphalt. All right. The reason why we make it hot is because the mix has to be hot to transport, to be able to work with, to be able to compact and place. All right. If I take cold aggregate and mix it with hot asphalt, all the heat comes from the hot asphalt and transfers to the aggregate. So I got to heat the aggregate. Okay. And I got to get the binder in there. Then I got to mix them. All right. I want to mix it up so it's consistent. Right. Okay. If you do any baking or, mixing anything at home, you don't just mix it for 1 second and then discharge, right? I got to mix it until it's uniform, whatever it is. Then I've got to be able to maybe store it again from my work in North Dakota and other places, maybe less. You don't have as many, this looks like a permanent setup, right? A permanent plant. This isn't one that it looks as much what it looks like on a portable plant. But either way, you still have some storage often at an elevated temperature. Again, I don't want to let it cool it off. And then I've got to weigh it and dispense it. I got to put it into a haul truck to head out to the site. Okay, that's my primary functions. So, what I tried to focus on, knowing that this is a recertification class, all right? My job is not to, go through every little thing of a plant before like you've never seen it. Many of you have seen it, you've tested at it, you do mixed designs at it. What I want to talk to you about is the common pain points, all right? What are the common locations for issues, all right? And so these are the items to check to ensure quality production, making sure I'm meeting specs. So if something goes wrong, I'm thinking about one of these areas. Now, I could have circled the whole damn thing at this point, right? From the amount of things I circled, right? We could come up with a lot of different things, but these I would say are the most common. So I'll try and go through these, give a couple minutes on each. So the first one, all right, if I go in order of kind of making the mix, is number one, stockpiles, okay? Quality starts, all right at your feed material, at whatever I'm using to feed material. Now, okay, understood, North Dakota place, you guys don't have a lot of ledge rock, right? You're using a lot of gravels, right? That pits, etc., are opened up. You have to deal with the aggregate that you have, right? So I would say that you have one of the most challenging situations when it comes to trying to get good stockpiles, because you don't have these as many permanent aggregate sources that I can rely on, these kind of static setups. What do we see for best practices when it comes to stockpiles? All right, number one, try and have multiple stockpiles to reduce variability as much as possible. I think that's probably a particular challenge for you all, right? If I have many different products, I can make them very consistent. All right, and through processing, etc. But if I have just kind of one gravel source, that's going to be more challenging. All right, I do definitely, no matter what, I want adequate separation in between stockpiles to prevent cross-contamination. All right. So hopefully we don't do this. Okay. I was there for this picture. These are two stockpiles of completely different sources. Okay. And they're meeting. There's a person. Okay. Right there. They are meeting, I don't know, 25 feet in the air. All right. If the loader comes in and takes material from anywhere in here, what am I getting? Who knows? Right? Who knows what I'm getting? Right. So we should have some adequate separation. My guess is that's not a big challenge for you all. I'm guessing you have adequate space in your yards to be able to do that. All right. So where's my big X? Yeah. Don't do that. Okay. Um, Try and keep stockpiles without segregation. And just as a reminder, segregation is when we get the large materials separating from the fine. Okay. And how that happens is I put a pile of material down. When things are dropped, aggregates will roll. Okay. Bigger aggregates roll farther than smaller aggregates. Sand doesn't roll much, but a big stone does. So what happens is all my stone rolls down to the bottom and I get it real coarse at the bottom and it's real fine up top. That's material segregation. All right. If I do that in my stockpiles and the loader takes something from here and then here and then here and then here, I'm going to have inconsistency. All right. And then finally, moisture content. All right. Moisture content is important because I have to dry the aggregate, right? Okay. And so it costs money. Moisture in aggregates is the thing that nobody wants, right? If we could snap our fingers and remove all the moisture from aggregates, industry, people making the mix would save money, all right? And we would get better performance, all right? But we don't live in that world. So best is covered stockpiles. Again, given the portable plants that you have, etc., my guess is you don't have a heck of a lot of those, all right? Better is paving under stockpiles. So for maybe some of your static setups, having paving under stockpiles, because then the water drains and it's able to drain away. Best. Okay, well, not best. Covered is best, but that's better. If I can't, which again, I acknowledge probably that's very challenging, all right, for the couple of you. All right. As a minimum, I need positive drainage. All right, so that when the water drains through whatever the pile is, it doesn't just sit at the bottom. Okay, that's asking for trouble. All right, location number 2, cold feed bins. Okay, so my cold feeds, all right, the loader operator, I use the word first here. Okay, I guess stockpile, people making the stockpiles control quality first. But once we actually talk about making the mix, right? The loader operator has a heck of a lot of input, right? I'm interested if how many of you have spent significant time in an asphalt plant before? I don't know if you can raise your hand. There is a raise hand button. If you're, yeah, I see you on video. Thank you, Don. All right. Significant time, right? I think it's a good idea, no matter, especially if you're testing this material, right? Excellent. Thank you all. The loader operator is the first kind of line of defense, if you will, right? If the loader operator's having a bad day, the plant is going to show. Okay, plant's going to show if the loader operator's having a bad day. So they really have a tough job in a lot of ways, especially if you had a lot of cold feeds. Okay, now again, understanding the materials that you have, you don't have as many cold feeds as others. And as I've kind of talked to Mike and others, you probably have some plants that are almost limited design-wise by the amount of cold feeds that you have, that you don't have a lot, right? Okay, but still with that, their job is to put the proper material in the proper bin, okay, to extract from the stockpile without getting into any segregation. Generally, what I generally hear is stay out of the lower foot of the pile. Don't drag into the pile, right? I'm getting a little bit of whatever the pile's sitting on, the moist material, all right, the most moisture is down there, and any segregation. So try and stay up and try and keep the bins full without cross-contamination. Okay, plants should tell you if a bin is empty, should, okay? Are they perfect? No. Okay. So this is actually an older image that shows cross-contamination. This is material that's supposed to be in this bin. Well, it was kind of dumped into both, right? Does the plant know that? Does the plant know that I dumped the wrong material into the wrong bin? Nope. It's not that smart. Okay. It's going to say, yeah, I got something in here. All right. But, well, there's no way my gradation changed that much. Well, here you go. Okay. So keeping these full, staying out of contaminant or bad areas, etc. This picture is from North Dakota. All right. As an example, some of the materials he used. So don't do that. Conveyor belt. Okay. The conveyor belt is the next spot. All right. Again, knowing your production, I've focused on drum plants here. All right. Just knowing that drum plants are more common. All right. Batches have a couple things to themselves, but I just didn't think it was worth it given the limited amount of time we have. Drum plants are only as accurate as its scales and the moisture contents. Okay. We are when we do a drum plant with people in the mix, people making mix, right? They are assuming a moisture content for the aggregate because when I weigh it on this belt, it is wet, right? Again, it might only be 1% moisture, right? It might be very, very dry, okay? But it has some moisture that we have to drive out, okay? And it's wet when we weigh it. And it's going to go into a drum and then hopefully get fully dried so its mass is going to get reduced. So knowing that moisture content is important for consistent production, right? Because that's why it's a quality control or a process control term, because the contractor needs to know it to meet specs, right? Moisture content of the aggregate doesn't get me performance, right? That doesn't get me the end performance. That's why the agency generally doesn't care as much, but the contractor needs to know it in order to meet the specs, right? Okay, so that's where this measurement is important. I do know you guys still, I believe, still do belt cuts for gradation, etc. Something similar on those. Okay, most states do it on the mix after it's made. Okay, but understood that as well. Wrap. All right, everyone loves them some wrap. All right, because it's free asphalt. Right, asphalt I don't have to pay for. Okay, the trouble is it's old. Okay, so I could talk your ear off if you want about how to design for asphalt, for the asphalt and wrap and the old age wrap, etc., and how to handle that. Okay, but from a production standpoint, you really need some extra care to effectively use wrap. Wrap is not just something I throw in a mix and be like, that's fine. Okay, not for spec mix, not for agency mix. All right. Wrap asphalt content is key to maintaining mixture. This is a picture I took of a wrap source near where I live. Okay, I got a little bit of everything in here. Okay, I've got what looks more like dirt. Okay, old wrap, real old wrap, slabs of old wrap, and new plant waste. Okay, little bit of everything. Anyone ever heard of a gawk pile? God only knows. Okay, gawk pile. That's a gawk pile, right? That's not very consistent. So for wrap, the trouble is by the time I make the mix, all right, it's almost too late. Quality begins at the original source and processing. Now, with a lot of your mix production, right, this is maybe less on the processing, but when you're in a remote location and the wrap you're using has come from milling the existing road, right? Okay, that milling operation really is my wrap generation. So it's the milling that kind of gets me my quality. So quality control testing during processing and crushing is important. Extra attention to wrap moisture. The finer the wrap loves moisture. Okay, loves it. It doesn't want to let it go. This is going to be your one that has the most moisture, and the finer it is, the more it's going to grab that moisture. So this can have an oversized effect, okay, on the amount that the contractor can produce, all of that. Okay? If I have really wet wrap, it takes a lot of energy to dry it because I don't heat the wrap up directly. I don't put the wrap under a flame. I can't. I destroy the asphalt, right? And actually burn it off, flash it off. Okay. So I don't do that. What I do is in a plant is I superheat the aggregates and then put them next to the wrap so that the heat transfers. So I got to make a lot of energy. I got to expend a lot of energy, fuel, whatever it is, to heat the aggregates, to heat and dry the wrap. So that's why moisture content is so important to understand. So these are just numbers, just an example of why knowing the wrap asphalt content is so important. Okay. This is just an example where I'm using 30% wrap. If the design asphalt binder content is 5%, but the actual stockpile is 0.5% less, right? Okay. So if you do the math on that, you end up with almost 2/10 less liquid than I should. Okay. That means too little binder. It's going to be a stiffer mix, dry mix issues, volumetrics, density, all of that. So knowing the wrap is critically important. All right, let's talk about binder, right? Binder storage, whether it's in a tanker truck, all right, for your remote locations, whether it's in a static location that has tanks, vertical, horizontal, right? Same kind of things apply here. Ensuring that the correct asphalt binder is used really is an important QC function. All right. Again, probably a bigger issue for those of you that work in static setups. All right. Somewhere where you have multiple tanks. If I'm in a remote location, I'm only using one binder for a job. Okay, this might be easier, right? I bring in the tanker, etc. But in those static setups, I got to worry about tank management, inline blending. I'm not a huge fan of. You can do it for warm mix, etc., but it does take some extra care. Then fines, all right? A particular interest of mine, fines, the baghouse fines, the number 200 material is an important part of an asphalt mixture. Small changes in the dust in the finest portion of our mixture has a big impact on how that mix behaves. I don't know if any of you have seen this, all right, but the same mix design, right? Same mixture, same gradation all the way down. The difference between 4 and 6% dust is huge. Huge. Doesn't sound like a lot, right? But it is, right? So when in a plant facility, the contractor has to consider the factors that affect the effectiveness of the baghouse. Because the baghouse that's kind of knocking down the dust that's created in our drums, all right, we don't just vent that to the atmosphere. We got to knock it down with a house of bags, baghouse, all right, knocks down that dust. We don't want to just waste that dust. No one is generally asking for a bunch of dust. So the contractor wants to reuse, all right, put it back into the mixture, all right. When we put it back into the mixture, unless it's being weighed in, which most plants don't have the ability to do, all right, how it gets pushed back in changes. How wet the material is. Okay, what type of aggregate am I using? The production rate. All of those things affect that feed rate back in. So again, it's a potential source of inconsistency, right? Where I have good air voids here and now I've closed them up, or now I have none. Well, what's going on? I haven't touched the plant. Okay, well, but is my dust feed uniform? Okay, so that's where this method of reintroduction into the drum, is it controlled? All right, or is it just being fed basically at how hard the dust is coming in? All right, when we talk about loadout, I've made the mix, right? I've made the mix. Silos, again, all different sizes. These are the bigger ones for, again, the more static setups, but you can have smaller ones for more portable setups. We need to consider the time and temperature and the segregation potential when using silos. All right. We don't want to segregate the mix by storing it. We don't want to cook it by storing it. Okay. Now, again, you are using primarily belly dumps, all right, and windrow paving. Okay. So when using that, there's less of a need for silo storage because the truck doesn't have to wait, right? I can dump, I can come back. The amount, and this is coming from someone from the Northeast, I had never seen a belly dump truck in my life until I joined Federal Highway and started traveling around the country a little bit more. Okay. No one uses belly dump where I've grown up and lived most of my life, right? We have to wait for the trucks, right? So we need a lot of trucks. I really like the idea of belly dump so kind of that I can bring it out to the site, discharge it, and come back, right? I can get more done with less trucks. It's very good at that. Okay. It also reduces the need for having to use a silo, right? Because I don't have to wait for trucks to discharge it. Okay. There's more challenges, I would say, with windrow paving once I get to out in the field, right? Okay. Having the proper windrow, having the right amount, making sure that's enough, it cooling off, etc. Okay. But maybe there's less pressure for you to use silos, but we still need to load it out effectively. All right. Load it in the haul units to prevent segregation. This is typically how I've done it. You don't want to do it one big dump, right? Why? Because the big aggregates roll down to the bottom, right? So I get all coarse and fine up top. We don't want that. Okay. So I know these are best practices. That again, for some of you, this is the fourth time you've gone through certification. And you'd say, we know that. I've seen stuff like this last year, right? All the things that I talk about kind of some of these best practices, most of them I see at least once in a year. Okay. So it's not like something that we never see anymore. For those that still do a belly dump, again, as I understand, that might still be something that's around Bismarck or other areas. You still want to do multiple dumps. You're not just putting it into one mass so that it segregates. All right. That's why we kind of say load out the front, load out the back, then do the middle. It eliminates some of that roll down potential.